So, let me make sure I understand your question. Is your question this?
I don't think there were parentheses, but yeah.
Huh?
I don't think there were parentheses in the book, but yeah.
Oh, no. So then now it's a totally different problem then.
Oh, okay.
If there aren't any parentheses, then that's all it is. And so the only thing being raised to the third power would be I.
Okay.
And that's a value you're supposed to memorize.
Isn't that negative I?
Yep.
Oh, sweet.
So that would be negative 5I. I have a feeling. Now how would this be different?
You do 5 to the third.
Yeah. So it'd be 5 cubed I cubed, so it'd be 125 times negative I.
Okay.
Yeah. So that would be two different problems.
Okay. And then with negative I parentheses to the 71st power.
Oh yeah, I remember this one. Negative I 71st.
And then I said there was 3 left over. I put negative I to the third.
Okay, negative I to the third. Because negative to the 71st power is still negative. I to the 71 is the same as I cubed. What's I cubed? So then what do you get at the end? Yeah. You just can't forget that poor little negative dude. He's still there. He's hanging around.
Okay. And then the more lengthier probably is in 11.5, number 39.
Oh yeah. Oh yeah. All right. So if I told you u squared minus 2u minus 35 equals 0. Well, what would you do? How does this factor? 35 pretty much only breaks up as 75, which would be negative to make negative 2. Yeah. So you get u is 7, and u do be. But, I don't know if you were squinting at it because it didn't look the same. But of course, here, so if I would have had this problem instead, you see how it's the same problem I just did. What did I let u equal? What did I let u equal? What did I let u equal?
Oh,
I let u equal, no.
No,
What did I replace with u? I let u equal 10 minus rad x, because that's the part that's repeated.
okay.
That's how I made it look like this.
Okay.
So am I done here?
No.
Because the original problem has x's in it, and I haven't said what x is yet. But what was u? No?
The
10 minus rad x. So you replace this with 10 minus rad x. And then you got this problem to solve still. 10 minus rad x. Got to solve those two problems. Well, this is a wedding where the bride knows a lot of people, the groom doesn't.
So on the last,
Is that cool? I'm sorry. Is that all right? Okay.
on the last question on the quiz, where it's like C equals 13 and A equals 5, and find C.
Or whatever you had, yeah.
Or, yeah, find the hypotenuse. So like you had to switch them, right?
I didn't say find the hypotenuse. I said find the missing side length,
Or,
where
yeah.
C is the hypotenuse, as it
So,
generally is.
Yeah. So like you're supposed to subtract, or
Yes.
yeah.
So if you just are nice to yourself, draw a little right triangle. Here I know C is, what was it?
13.
Yeah, whatever. So if I would told you C was, if I said C is, it doesn't matter, 11, and A is 2, you would put C, you put 11 there, you put like a 2 here, and then you don't know what B is. And what's the formula?
Squared.
A squared plus B squared equals C. And then all you got to do is plug stuff in. There were people making mistakes because you weren't keeping things organized for yourself. What's the general principle you're going to use? Write it down. Fill in what you know. Solve it like you always would. You're not going to get things on the wrong side and do weird things. Keep it organized. Why make it harder? It's already hard enough, right? And then you just plug in what you know. So here this would be 2 squared plus b squared equals 11 squared, and then subtract. Yeah, so if you know the hypotenuse, you know you're going to have to subtract. Because the hypotenuse is the sum of 2 other things. So you got to subtract to figure out that missing thing. If they give you a and b, it's going to be squaring and adding, and then square rooting it.
Also, the I always goes before the square.
Yeah, I know the book says, if you look at some of the answers in the back, it gives you 2 different ways. But you always put the I in front, because if you don't, then it starts to look like it's inside the root. And think about square root of I for a second. What the shit would square root of I be? All right, thank you. I don't know if you guys, some of you guys might remember, I meant like a half turn like that, like a quarter turn really. So square root of I would be half of that. Square root of I would be a 45-degree turn, which we don't know what the hell to do with that yet. But it really does follow the same idea, to be honest. Let's just not do that.
So Lisa, you tell them we're gonna do this like later.
Depends on how far you go. Yeah. You'll do a little bit of pre-calc, but if you do pre-calc. All right, let me see. Who just came in, didn't get back their stuff? Anybody not get their stuff back? Oh. Oh, yeah. Okay. Here's the answer keys for a couple things. One thing we didn't do. For example, on the other side is the one thing we did do.
Where's that formula come from?
From observations of the real world. Thanks, Jeff.
I wasn't here for that class, but I can relate it. If I have I to the 0 is going to be 1.
Yes.
If I have I to the 1 is going to be I.
Yes.
And I to the second is going to be -1. And I to the third is going to be minus I.
I, yes.
Okay.
Now the fourth is 1, and the whole thing starts over again. Yep. Yes.
For B, I got x equals 2 to the square root of 3 plus 1. Is it supposed to be 2 plus or minus the square root of 3?
Definitely not.
I'm sorry.
Because what'd you get before you got 2, rad 3? What was your original rad?
Square root of negative 18.
All right, so if you have square root of negative 18, that is the square root of negative 9 times the square root of 2, right? Square root of negative 9 is 3. Square root of negative is I. But when you took the square root, you have to put a plus or minus immediately. So there's a plus or minus in front of this. So there's a plus or minus in front of whatever that is. They can't put it in the middle suddenly and make it 18 is made of 9 times 2. You can't suddenly make it plus or minus here in the middle. It doesn't make any sense. It's a part of the coefficient of this whole thing, whatever it becomes. So normally that mistake happens when people put the plus or minus too late, and they just kind of stick it in front of the radical wherever it is. But no, the radical was this. You rewrote it, but there should be a plus or minus in front of it. All the way down. That's why you write plus or minus the minute you take a square root. You write that down. Just like in part A, here, should have happened.
B.
All right. Anything else from homework or the quiz?
Can we do this test version number 4B? I thought I had it right. I did. Is this-
You could ask me individually,
Okay.
because you do the same thing I was saying earlier.
Right.
You put stuff in a squared plus b squared equals c squared. You know a and c, right?
Yeah.
So you put those in and you solve for b. So you subtract that thing squared.
So your answer would be what? Like, say you squared the A and the C, you subtracted from it, your answer should be the already squared version?
Well, then b squared equals that. So all right. So a squared plus b squared equals c squared. If a was 6 and c was 10, then you would put 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. B squared equals subtract 64. Take the square root. Why do I only put an 8, not a plus or minus 8? Because this idea is lengths of side of a triangle, so you don't put plus or minus. So some of you guys never put a plus or minus, or never did, and now you will. But here, why don't you put the plus or minus like we should? Because it's a physical side length. You don't include the negative length. Yes?
In response to, so how far are we going to get into the textbook?
Hopefully, we'll see. I don't know. Yeah, it all depends on if we can be efficient with our time. Yes?
A squared plus b squared equals c squared. Is that a Pythagorean?
Yes.
Here.
And it only works for what kind of triangles?
Okay.
Right.
Right triangles. I like it. There is a modification. It's got like an extra term here if it's not a right triangle. It depends on what angles are in the triangle then.
Okay.
This is the nicest form of it. If it is a right triangle, you don't have to write the extra shit down.
And
But there is extra stuff you could put if it wasn't a right triangle. I just want you guys to realize that.
Okay, and this is the imaginary numbers.
No, that one, yes.
Yes.
Yes,
Okay.
sure.
So you gave us a reason why you don't use plus or minus because it's a physical thing. So what's the logic behind using plus or minus?
So if I ask you, give me 2 numbers that multiply to be 12. Give me 2 numbers that multiply to be 12.
4 and 3.
All right, and if I said -4, -3, that's still right, right? But if I said 2 people's ages multiply to be 12. -3 and -4 work as numbers. Do they work as ages? So word problems put extra restrictions on the allowed answers. So math says these numbers work. And we go, that's nice math. We need these people to be born. Otherwise we wouldn't even know. Somebody's going to be born in 3 years. So they're -3 now. What the shit are you? You're right? Do you see what I mean?
Yeah, okay.
So I really want that understood. It doesn't mean that there's something wrong with those numbers. It just means that the situation I'm in doesn't allow certain numbers. Yeah. I like it. Okay. Hope they got to turn this dude on there. Oh my God. Okay. All right. Now, if there's no other questions. It seems like maybe everyone who's coming is here. I don't know. Oh, did you? Who didn't get their quiz back yet? Anybody? What's your name again? Grizel. Okay. There is an answer key for that sheet from the other day. Cool. Blah 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 blah. Okay, cool. We're getting into chapter 12. Oh my God.
Something new.
What chapter is that on?
Say again?
What is chapter 12?
12, yes. This is section 12.1 we're going to talk about right
Is
now.
this chapter 11 on steroids or is this a new concept?
This is a new concept. Not brand new. It's built. It's built on other things. Did I bring those? Oh yeah, they're printing out. All right, I have to go run and get those. All right, I have to lay down some groundwork. So section 12.1 kind of gives us a few concepts that will lead into the rest of this section. Just a reminder what a function is. Can somebody tell me the definition of a function? Oh shit! Somehow I related it to Highlander, the movie and the TV series. And somebody goes, I don't know that stuff. Yeah. Look it up. Don't watch the second movie, it's stupid. For every something, there can be only something. So what's true about a function? Is this a function? Is this a function? Yeah. For every input,
It's only one
There's
out.
only one output.
which is normally x, but we know it could be t for time or something else. but normally, traditionally, it's x. For every input, there could be only one output, which traditionally is y, but it could be whatever, depending what the function represents. So is this a function?
No.
Because, for example, for this input, there is more than one output, so no good. It's like, where's the ball at time 2? Well, it's here and here and here. I'm like, what kind of ball is that? Has that been militarized? What the hell's going on? How are we doing so far? That's review. So what kind of test do I use then visually? That is the vertical line test. So like vertical line test tells me if it is a function. I like it. All right, so that's going to come up here in a little bit. Let me get your opinion about this and maybe an answer. Given f of x is square root of x minus 2 and g of x is x minus 1 over x plus 5. I like it. Let's start off with an easy one. Find g of 3 b. Find f of let's say 18. All right, so can we do those two things? Again, this is still review.
First one forward.
No, careful. I understand where you got that from, but where's the 8? In the bottom. So how in the world do you divide by 8 and get bigger? So there's that. Good. Yay. So yeah, g of 3, you plug a 3 in for x, you get 3 minus 1 over 3 plus 5. You get 2 over 8, which is 1 over 4. Yeah. 4 should stay where there's more, right? 2 divided by 8 can't be bigger than 2. How about f of 18? How do I know I'm going to use this one? Because that is the f function. Why did I use that one? Because that is the g function. Don't make more of that than it is. So that's why we give functions different symbols, so I know which one to use. Square root of 18 minus 2 is square root of 16 is 4. And people kind of freak out and put plus or minus shit there. No, square root of 16 is the positive root. Don't overthink that kind of stuff. All right, all review. So here's the one that's not quite review. I think I gave you one like this before, but it's just because it's not that big of a step from what we did. What do you think about, let's see if I can make this work. G of f of 27. I like it. Now, real quick, what did this mean? G of something. What do I always do with that thing that's inside? I put it in place of x in the g function. Do I know what's inside this? G of this. Do I know what this is yet? So it makes sense my first step is, what the shit is this? So I can then put that number in g. So what do I always do with order operations in the problem? I always do the innermost thing first. So I got to know what the hell f of 27 is. So it's like a two-step problem. It kind of makes sense. There's two functions I want to use. There's a two-step problem. How do I do f of 27? F of 27. So that means take 27.
Oh, I'm sorry.
Oh my lord.
So 18 times 27.
So it's x
What?
You plug in 27 minus 2.
Into that.
What does f of x say to do?
Plug it in.
It says take the square root of that thing minus 2.
Yeah.
So what's f of 27? Let's see. Square root of 27 minus 2.
Oh, gotcha.
Oh, I see.
Oh, okay.
I'm working the inside out, right? That's all. Let me finish this up and I'll show you another example. It's not done yet, right? So what did I do? Put 27 into f because that's what it's asking me to do. Then I figured that out with square root of 25. 5. Now I know what the heck to put in g. From the beginning, I was like, what do I put in g? I don't know yet. Let me figure that out. Okay, now I can put that into g. What do I do with the 5? Plug it into the g function, right? So this is going to be 5 minus 1 over 5 plus 5. I just put a 5 in, right? If you could put something into f, you can then take your result and put it into g. It's just substitution still. It's just that here, why was this easier? Because I told you it was 3. Here I said, I'm not going to tell you. You got to do some shit. I'm like, all right, say it, damn, just give me a number. Shit, all right. What is this number? It's 5. Oh, okay, now I can put 5 into g. What do I get? I get
2 over 5.
good 4/10, which is 2/5. I like it. So, I mean, for example, if I said simplify this, shit and a half. Let's say it's simplified. 4 minus 7 cubed. What would your first step look like?
Subtracting.
Yes, so what would you write the next line down?
Negative 3.
-3.
Square. I mean, to the third power.
And that stuck around, didn't it? It's like waiting for you to finish this. Look, that G is waiting. It's like, all right, come on. Okay, now I can. Same way. What did you do? You started working on the stuff on the inside. What about the stuff on the outside? It just comes along waiting. So G of, I don't know yet. G of, I don't know yet. G of, I don't know yet. G, oh shit, now I know. I can put it into G now. I can do that last step. When am I going to cube? As soon as I'm done with the inside. When am I going to put something into G? As soon as I'm done with the stuff on the inside. It's not that big of a step from here. They just didn't tell me 3. They told me, here's how you find a number. Okay. Yes?
And if it was 4 times 7, you would distribute the 3 to both?
4
in
times
parentheses,
7.
if it was-
Oh, yeah, don't get hung up on that too much. Right? Yeah, okay. Because I wanted you to realize you've already done this kind of thing. It just doesn't look exactly the same, but it's the same. The outside thing stays the same while it waits for the inside to figure itself out. Same idea. I like it. Okay. So this thing is called composition of functions. Yes?
Yeah, I remember seeing that like on a test, like as a bonus or something, and there was like a billion parentheses that were just on drugs, you know?
Yeah, but so for example, if I put, well, let me do this. Let me ask you, let me give you 2 freaky questions now. D. Freaky already. So what have I said? What is, let me see. What is, let's see if I can give you a nice one with these things. Yeah, what is f of 3? What do you have to figure out first? Got to figure out what f of 3 is. I just happen to be using the same function twice. It's not that big of a deal. So what does this become here? Square root
1.
3 minus 2, I like it. So square root of 1, which is 1. So what's the f of 1? How do you do that? So I figured out the inside number finally. Now the outside dude's like, all right, I get a turn now. So f of 1 is square root of 1 minus 2. Square root of negative 1, which is I. I squared is just negative 1. Square root of negative 1 is I. Yes?
What happened to the 1, the square root of 1?
Square root of 1 is 1. Yeah. So that is that. Now I can plug that in because now I know what that is. So now I can actually plug that thing in. All right. So what is here? What is f of g of x? please notice this does not say multiply. This is f of g of x. Put g into f is what it says. What I always get is people think that f equals. F don't equal shit. F of x equals this. So f of this means take this, plug it in. Well, what is g of x?
X minus 1 minus over
Yeah,
X.
f of, replace this with what it is. And people kind of give up here, but oh well. It's kind of very brutish. You just take that shit and you just jam it in to this one, right? So what does f do to anything? It takes that thing and it puts it
Yes.
right there. So what would this be? This would be the square root of x minus 1 over x plus 5
Minus 2.
minus 2.
This escalated quickly.
What?
So this escalated quickly.
No, it didn't. I really want you to understand. How much work did I have to do? Was it a lot more work because this looks ugly? No. Look, I just put it in there. In fact, this is easier than what we were doing because I can stop here. If it was a number that I had to put in here, then I have a lot more work to do. So to be
So
honest,
that's the answer.
yeah.
I
Oh.
thought you had to solve for
Now, how can you solve? How can you solve? Do you know what this equals? Is there an equation here? No, and don't say there's an equal sign. I'm just rewriting what this is. There's no equal 7 or something that I have to square both sides and do shit. I am done. Now, technically, you could like get LCDs, but what good is that? Now, please, dear God, if it said 3x minus 2x, then I'd hope to God you make that x. You do have to do simple simplification. But there's really nothing to do here. You're done. You understand what I'm saying? I mean, did the idea change?
Too good to be true.
What's the idea of functions? Whatever's in them, I put it in there. Did it change? No, there's a g. All right, I'm going to take what g is and put it in. Okay. That's the idea. It doesn't change.
Understand, though, that's like a traumatic thing. Like we're used to. It's like math is a really bad relationship. It's an abusive relationship, and it's just we're ready for it to like mind fuck us all the time. Like
Yeah, you got to
That's
stop
why.
that. No, I know it's hard. I know you need some math
Gotta
therapy
stop
or something
them
maybe.
somehow.
But you keep expecting that, so you twist things so it seems like that's what's happening. When in reality, all right. What is
That's like factoring and then going backwards.
what's f of w?
You don't know?
tell us.
I don't care. Yes, I did.
Probably learned-
What is f of anything? You take that thing and you put it there. So what is f of w?
W minus
Square root of w minus 2. What's f of a? Square root of a minus 2. F of x is square root of x minus 2. So f of w is square root of w minus 2. Functions are so single-minded. They say, whatever the shit's here, put it in what I am. Just put it in. So here, what was all this shit? I put it in. Bam. It doesn't matter what it looks like. So what is f of a plus w squared minus 71 L?
Square root of a plus.
Square root of a plus w squared minus 71 L
Minus 2.
minus 2.
And
Did I
that's the
have much
answer.
thought? Was there much thought there?
But that's the answer.
Yes, because there's no simplification I could do.
Sweet.
Again, what's this function say the look has to be of the answer to begin with, unless there's something I can simplify? F of something is the square root of that thing minus 2. That's going to be what it looks like. Whatever I put here, you put there. That's all function notation starts off as. Now, then if it's a number, maybe you can simplify it. If it's an expression, maybe you can put some like terms together, right? But the first step is put the shit in there. Yeah.
So it wouldn't be f equals that answer.
Never f equals. I'm sorry, I'm making a big point out of you right now. If you say f equals something, that doesn't make a damn bit of sense. It's got to be f of something equals, which is pretty much what I had up there, but I'm just rewriting it for some reason. F can't equal something. It's like if I ask you this, what's the answer to this? What are you going to say to me? What do you say? How do you do that? What's the answer to this?
Square root. There is no answer.
Why? What's missing?
All the numbers.
Something on the inside is missing. Okay, so if you say f equals, I'm like, what the shit is that? There is something on the inside missing. You're not telling me where you evaluated the function at. So that makes as much sense as that. Tell me the answer. Square root. What's the answer? Square root of what? Shit. So if I said square root equals 2, you can't say shit about this because you don't know what's in there. There's nothing in there. It doesn't make any sense. There's not even 0 in there. It's just empty space. Doesn't make any sense. Okay. All right, how are we doing? I really want you to understand. So here, let me give you an example. We have to do a little extra something. What is f of 3x minus 1? Try to do that on your own. Nothing major, crazy. The first step is always the same with functions. Once you know what the inside is, plug it in. Yay. This is the first step is,
Plug it in.
that's the form of it, right? Whatever the hell's there, goes there. Now, is there something else I can do? What do you get?
3x minus 3.
Done.
So
I mean, so if there's any simplification, you do it. But what's the first step? The first step is, whatever that is, you replace x with it. That's all function notation starts off as. And then any simplification you do after that is just because we want to simplify stuff. It has nothing to do with function notation. It's just, well, there's a better way to write that. There. Oh.
like matching socks.
All right. How are we doing? Matching socks. Okay. Whatever makes it work. All right. So. Here, you guys try these.
Real calls.
Uh-huh.
It's not real calls.
Let's see. Let's see. Oh, why did I do that order? Make this easier on myself. Yeah. That one's for Ivan, I think. Be really careful with part B. I'll give you a little hint. It's a one-step problem. There's too much to that.
For A, it's HGA or 9?
9. That wasn't German, sorry. Oh, man. Yes. That's what I'm talking about. One step, you're done.
Oh,
You can't distribute the root across subtraction. So you're done. I am not. Again, I said part B was a one-step problem. Doing more than one step, that is bad. Let's go ahead. You code? Anybody else like to get their quiz back?
Hey, Jeff, I have a question.
Yeah.
Where did you get your,
The other side's not so much. Yeah. Two options here. Yeah. Two names I thought. I had the R down, but there's a Ryan and there's a Ricardo, so I was like, which one?
yeah, so,
Yes.
so where do you get your honors from?
The what?
Your honors team? Honors?
Oh, the Purely?
That's purely.
Yeah.
Oh, I didn't know they made it in class.
Yeah.
Yeah. Come on, tell me.
Oh yeah, I forgot to.
$1.50.
All right, guys, let's take a look here. This is h of 4 minus square root of 9.
9.
Real quick, my girlfriend knows German, so we'll go shopping. I say, how many of these do we need? 9. And I'm like, 9 of them. Sorry.
Does that mean none or no?
No.
That means no, but I pretend like it means 9. 4 minus 3 is 1. And h of 1 would be 5 times 1 plus 7, which is, there you go. Do the inside like we always do. Do the inside first, and then we can plug it into the outside guy. So here, what do I replace the inside with? What is f of x?
Square root of x squared minus 1.
So f of x is x squared minus 1. And I plug that into g. So it'd be 4 minus square root of
X squared.
x squared minus 1.
Yeah.
Done. Now, if you're
We
thinking
don't need that first part, right?
here,
Yeah.
not really.
Yeah,
You
I
just
would-
see what f is and you can plug it in. That's beautiful. That's what I meant by it's really a one-step problem. But you can't simplify this, dear God. Please, dear God. Square roots cannot go across subtractions because they're not based on subtraction, they're based on multiplication. Right? I can do the square root of 9x squared, for example, right? What's the square root of 9x squared?
3x.
Yeah, don't worry about absolute values. What's the square root of 9 minus x squared? I'm done. Because that's subtraction. It doesn't. So multiplication, it's all day long. It's what it's based on. Subtraction, it can't do shit to that.
Because it's not like terms.
This is not like operations. It's not what it's based on. So this is h of f of 4 minus the square root of 4. So this is h of f of 4 minus 2 is 2, which is h of
2
2 squared minus 1. Is everybody with me?
Yes.
Do the inside, step out. Do that, step out. Do that so I could have like a billion letters, which I won't. But I could. H of 4 minus 1 is 3. And when you plug a 3 into H,
5 times 3 plus 7.
15 plus 7 is
22.
22. How we doing?
Good.
Sweet. All right, so don't make more of that than it is. That's very simple-minded. The first step is always the same. Anytime with functions, you just substitute. Then you see if you can simplify anything. That's another step. The function doesn't do that to you. Just whatever's in there does it to you. Okay. So, let me see. Do I want to give this to you yet? Blah, 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 blah. Yes, let me give this to you. Ooh, I like it. So I want you to try all the problems in the front of this.
feel good about this section?
It's okay.
Well, they do, well,
It's means.
so the O means times, correct?
No, I'm going to talk about that right now.
Okay.
All right. So you guys remember my little rant about the root symbol, and it really should never have been invented, but it was, so too bad. Do you see how much sense this makes? That really, hopefully now makes a lot more sense, but it makes total sense. I take whatever this is and I plug it into H, so of course I first figure out what that is. Unfortunately, the fantastically smart former math people, they said, well, that makes too much sense. Let's make the actual symbol this. I like this one. This is going to be the hog function.
What?
That means this. And the way I read this is that's a little O that stands for of. H of G of 9. H of G of 9 makes more sense. The minute you see this weird shit, which normally when I start off it's the fog function, which is what students feel like they're in. So the fog function, you can rewrite that as F of G of X, which makes infinitely more sense. So I'm sorry if this exists, and I want you to know what to do if you see it. I have no idea, truly no idea.
Oh, God, I hate that.
Why they did this, I have no idea. But I have not enough knowledge to make a time machine yet. Maybe I'll go back in time
Are we
and
gonna see that
kill
in
whoever did this shit.
calculus and stuff? Fog?
no,
No.
not really. It's hilarious
it'll
to me.
Stop,
This
it'll
is the
stop right
only
here.
real level that you see this shit at, and I'm
Oh,
like, why
God,
does it
thank
exist?
God.
I'm really sorry.
Oh,
Sorry.
easy.
But it's like any field on the face of the earth. There's things that are done that you disagree with. Somebody else probably, another math person loves this shit. And maybe they have good reasons. I haven't heard it yet.
Looks retarded.
But now you know what it
This is
means,
like all
right?
parentheses.
Now you know what it means. So go ahead and try to do that
Makes it a little more clear.
sheet. I wanted to give you some examples of that because you're going to see it. Let me see, who else just came in? Okay. Anybody else not get their quiz? Oh. Just sending it, right? Is it you? Good. And then here's the answers for this stuff. That's the one we didn't do yet, so I gave you the answer for it. And that's the word problem one. I figured I'd go and make an answer for that.